Let's take a minute and reflect on what we did yesterday in class when we did our activity moving from table to table and modeling rock transformations. So here's a list of questions that, before we go on to our final argument about the Grand Canyon, which we're going to write, we want to make sure that we can understand how the rocks of the Grand Canyon could be so many different types of rocks all in the same location. So here's a couple of questions that I want to talk about. The first one just talks about weathering, and it's a two-part question. It says, what process happens before weathering, and what process happens after weathering? So the thing that has to happen before weathering can take place is there has to be a rock there. So a rock has to form, because weathering is the process of taking a large rock and breaking it down into little, tiny, tiny bits of sediment. So in this process of weathering, which can happen from all the different ways that we've discussed before, like rain beating down on a rock or wind going across the rock, sometimes wind picking up other little tiny sediments and like running those across the surface of a rock. It kind of acts like a sand blaster. There could be ice or frost wedging where little bits of water get into the cracks of rocks and then breaks it apart when it freezes. And so we talked about all those different processes before, but we understand that before any of those can take place, the rock has to be at the surface where weathering is taking place. So you have to have a rock and it has to be at the surface. Rocks that are further down are protected from weathering for the most part. So then the process continues. The question goes on to say what happens after weathering. And the process that happens after that would be where the sediment gets moved to another location. So we have erosion taking place. And then after it's moved to another location, if more and more sediment get deposited on top of it, it compacts it down. And we modeled that with our candy sediment by pushing it down with the cup. And as that gets compacted, it can then go through the process of cementation, which is when it all sort of cements together into a brand new sedimentary rock. That's a rock that's created just from sediments from other bits of rock. They could be tiny sediments, they could be different sizes of sediments, all sort of mixed together. So the next couple of questions are going to be talking about the process of melting and uplift. So what happens before melting, what happens after? Melting can only take place if there's a heat source, so a rock has to be deep in the ground near where the mantle is. Remember, the mantle is soft, solid rock, but it's soft because it's so hot. And so for melting to occur, there needs to be a heat source, and that's going to take place deep in the earth. Rock cannot be melted by the sun. It's the sun that hits it is just not hot enough. Even on the hottest day of summer on the equator is not anywhere near hot enough to melt rock. But in the earth, absolutely, it's hot enough. So the next couple of questions talk about, oh, sorry. And then also, of course, we remember that melting has to then be cooling. So the next couple of questions talk about uplift and subduction. And so what I'd like you to do is take a look at your own work that you did yesterday with the different processes that you were at, and then also take a look at your path through rock transformations. And I'd like for you to take a moment in the discussion box below to answer this question. What process happens after uplift? What process happens after subduction? And what type of rock can be uplifted or subducted? So take a moment just to answer a question about uplift and subduction and put it in the discussion box below.